What do we know about Venus's geography? Does it have craters, mountains or valleys? And what are arachnoids and coronae, unique features found only on its surface? Although Venus is nearly identical to Earth in size, it differs in almost every other way, including its geography. In this video, we'll explore what we know so far about the geography of our closest neighbor, looking at some spectacular images along the way. But first, let's establish some basics. We need to set a zero elevation, a reference point for altitude measurements. On Venus, we've set this as the altitude for the average diameter of the planet, approximately 12,100 kilometers. Compared to Earth, the average diameter falls about 3 kilometers below sea level. Since Venus has no seas, we use the average diameter as our reference point. Now that we've set that zero elevation level, let's discuss the topography, typically divided into three types for Venus. The lowlands, areas with negative elevation below 0 kilometers, covering about 40% of the surface, the deposition plains covering half of the surface with an elevation between 0 and 2 kilometers, and the highlands, regions where elevation is above 3 kilometers. The tallest mountain on Venus, Maxwell Montes, surpasses Mount Everest on Earth. At about 11 kilometers in height, it could be almost completely submerged in our deepest oceans if it were on Earth. The most fascinating aspect is its snow caps. Peaks are covered with what we call metallic snow. Recent suggestions propose that this type of snow is comprised of lead sulfide and other heavy metal salts such as bismuth sulfide. Maxwell Montes is at the center of a large elevated continental region, Ishtar Terra, in the northern hemisphere of Venus. The size of Ishtar Terra is comparable to Australia. The region is named after the Babylonian goddess of love, Ishtar. The surface of Ishtar Terra is also home to a huge crater, Cleopatra, right next to the peaks of Maxwell Montes. Two other notable continental regions, or Terrae, Aphrodite Terra and Lada Terra, are named after the Greek and Slavic goddesses of love, respectively. With Venus itself being the Roman goddess of love, it's fitting to name the most prominent regions after deities related to love. Aphrodite Terra is an equatorial region about half the size of Africa, extending almost two-thirds around the planet. Although much larger, with mountain ranges too, they are not nearly as high. The tallest mountains here are half the size of the mountains found on Ishtar Terra. Three distinct plateau regions are found on Aphrodite Terra: Ovda, Thyris, and Atla Regio. Lada Terra covers most of the southern polar region of Venus and is also home to a 3-kilometer high structure known as the Lada Rise. Lada Rise is home to another geographical structure, Quetzalcoatl Corona. Coronae are oval-shaped structures that appear only on Venus and Miranda, a moon of Uranus. Coronae are thought to originate from the upward movement of hot material in the mantle, creating plumes that elevate the crust into a dome shape. Subsequently, the central part collapses as the molten magma cools and it escapes from the sides, resulting in the formation of a structure resembling a crown. The largest corona on Venus is Artemis Corona, with a whopping 2,600 kilometers in diameter. It is located on the south of Aphrodite Terra. Another striking feature of Venus closely linked to the formation of coronae is the arachnoid. Arachnoids have never been observed on any other celestial body in our solar system. An arachnoid is a large geological structure on the surface of Venus that looks like a spider web. It appears as concentric ovals surrounded by a complex network of fractures and can span up to 200 kilometers. There are over 90 arachnoids identified on Venus, and we don't know exactly how they formed. They might be related to volcanoes, but it's also possible that different arachnoids formed in different ways. One idea is that magma from inside the planet pushed up, causing cracks. Another theory suggests that arachnoids might be a step in the formation of coronae. Speaking of volcanoes, it wouldn't be a proper video about the geography of Venus if we miss the opportunity to talk about them. Volcanoes are abundant on Venus' surface, as much of it has been shaped by its volcanic activity. There are over 80,000 of them, 167 of which are over 100 kilometers across. The second highest mountain on Venus, Maxwell Montes, is actually a volcano, named after the Egyptian goddess of truth and justice, Maat. Rising over 8 kilometers above the zero elevation on the equator of Venus, it is 868 square kilometers in area, truly massive. Venus is also home to another unusual type of volcano called pancake domes. They are thought to be formed when highly viscous lava erupts and cools under the immense atmospheric pressure. On Venus so far, we have discovered and identified almost 1,000 craters. Despite the abundance of craters, it seems that small craters cannot form. Due to the extreme planetary conditions, small and lower density objects with less than 50 meters in diameter quickly disintegrate before impact, and they don't seem to survive atmospheric passage. For slightly bigger objects, it looks like the atmosphere itself can slow them down so much so that they don't create any impact crater at all. To form a crater, an object must contain a certain amount of kinetic energy. Below a certain threshold, impacts are significantly smoother. Another interesting fact is that the craters we found on Venus are surprisingly very well preserved. There are not many hints of erosion and degradation, suggesting a very young surface age. The planet must have undergone a global resurfacing event no more than 600 million years ago. The largest crater on Venus, with a diameter of 270 kilometers, is the Margaret Mead crater. Superimposed on Earth, it would be almost the same size as Switzerland. Sorry, Switzerland, next time it will be another one destroyed by the forces of nature. Also, all craters have, unsurprisingly, female names. There is one named after Mona Lisa too. The central peak of Ariadne crater serves currently as the geographic prime meridian. Lowland regions of Venus are known as Planitiae. On the south of Ishtar Terra we find sediment Planitia with a comparable size to the Mediterranean Sea, about 3,600 kilometers in diameter. On the other face of the planet we find Niobe Planitia and Atalanta Planitia on the northwest. Atalanta Planitia is home to the lowest elevation on the planet, approximately 2.9 kilometers below the zero elevation level. The Planitia we find on Venus are generally very flat regions, with the occasional scattered craters and arachnoids. Venus is home to one of the most intriguing geography in the solar system. 80,000 volcanoes, pancake volcanoes, 11-kilometer tall mountains, metallic snowcaps, shallow and flat lowland regions, 1,000 craters, coronae and arachnoids. Is it really a twin to our Earth? Let me know what you think in the comments below. Thanks for watching.